Hi everyone, today I'll present to you our project called The Impact of Water Stress on the Growth of Cos, Iceberg and Mignonette lettuce, species Lactuca sativa. Our members will be Lauren, me and Millie. So climate change recently have caused a lot of issues to the world, such as increasing temperature, rising sea level and drought. This project will focus on one issue, which is drought. And due to drought, the world's water supply have been challenged as there's high evaporation to low replenishment rate. It's been estimated that in 2050, 52% of the world's population will be facing a water crisis. The agricultural industry uses 72% of the world's usable water, and in particular, Australia have used 67% of the usable water in 2019 to 2020. Shown in the figure here.
So as Min was explaining, our project intends to investigate water requirement levels and overall water stress on lettuce. So we decided that the aims of the project are to understand the minimum water requirements to produce healthy lettuce, and also to understand whether different lettuce varieties respond differently to water stress. Our objectives indicate the intended outcomes wanted from this study as being to determine the minimum quantity of water needed to maintain healthy plant growth, to determine whether lettuce can grow within a limited water environment, and to determine which lettuce variety, as seen in Figure 2, produces the best harvest with the least amount of water. From these, we have formulated the research questions for the project to be, does reduced water availability make lettuce growth decline? And if lettuce growth declines, what is the minimum water requirement for healthy lettuce growth?
The following 3 slides will outline the scope boundaries for our project. To begin with, this project has and will be carried out within the current coronavirus rules and regulations, analyse the effects of 6 different water treatments on cos, iceberg and mignonette lettuce. This project will be undertaken at 3 different locations across New South Wales, and this experiment will also dispose of the experiment materials appropriately and as per the manufacturer's guidelines. Lastly, this project will cost only $25 at each location. Throughout this project, we will only be utilising seedlings from Sunshine Grow Your Own, Scott's Performance Naturals Premium Potting Mix, Garden City 50mm square tube pots, kitchen scales, tap or tank water, measuring syringes or tubes to provide the seedlings with water, rulers and a soft tape measure to measure the growth of the lettuce, and a covered area to eliminate natural rainfall but also provide partial sun exposure.
Following on from Lauren, within our scope, we have set boundaries that the project will not be extending to. These include interaction or involvement from the general public due to this being a controlled project, causing any harm and or change to the environment, using excessive amounts of water or space, and we will not be impeding on public or council space as we will be using privately owned property. We will not be causing any risk to public health and or well-being, as this project does not use any dangerous chemicals or materials which pose serious harm to the health and well-being of the public. We are limiting the study to not look at any other factors, that is salinity or nutrients, other than water stress on the growth of the lettuce. This is due to the limited access to the necessary equipment and laboratories to ensure reliable results on account of the current New South Wales COVID-19 lockdown. We will not be breaching any current New South Wales government and or Western Sydney University's COVID-19 rules and regulations to ensure the safety of the public and the general.
So this is the project method. Before we start the project, I decided to do a little soil saturation experiment where I used a 5x5 diameter cup, similar to the pot that we're using. I found out that the saturation point of the soil of this volume is actually 13 mils. However, our watering equipments are limited in terms of measurement. That's why we increased the 100% to 15 mils. We collected seeds from Bunnings. So respectively, we collected cos lettuce, iceberg lettuce, and mignonette lettuce seedlings. We also collected the same Scott's Performance potting mix for the 3 of us, and also the same size pots. The setup area is located where the seedlings are protected from natural rainfall, but they still have access to partial sun. We measured the height, the circumference, and the weight of the lettuce every 2 days. In concurrence to that, we also record the temperature of those days. We also recorded root length at the time of transplanting, and we'll also record that when the experiment is finished. We water the lettuce every 2 days, assigned to these water stress level, and after that, we'll tabulate the data into Excel.
So this is our project's action plan, and it outlines all the specific tasks we need to complete across the semester up until when the final report is due. Currently, we are on track with our action plan, and we are completing all our necessary tasks within our given timeframes.
So this is our project progress. So far, we're up to day 37 of our experiment, but we're only showing our results till the 27th day, which is the 4th of September. So all of us had the same experimental setup as mentioned earlier, and these two animation is a compilation of the aerial, which is the top one, and the side view photo to show the overall appearance and height of the lettuce so far. So in the overall appearance, you can see that the 0% is starting to die off slowly. And also one of the 80% is dying, as well as the 100%. In this side view, you can see that the leaf is starting to droop off at the 0% and 20%, and also at the 100% and 80%.
So my lettuce variety is the iceberg lettuce, and I've set up my pots under my awning, which allows the plants approximately 5 hours of sunlight a day and protects them from natural rainfall. So far, all of my 18 pots are still alive, which shows how hardy the iceberg lettuce is. And I've observed the best growth within the 80% water treatment and the worst growth within the 0 water % treatment. In regards to having any issues with my lettuce, the only problem I encountered was on day 16, where I had gale force winds, which knocked a few of my pots over in the trays. I've since then put a barrier between the pots to prevent them from falling over and getting damaged or losing their soil.
The mixed mini net lettuce seedlings are located on the Central Coast in a regional agricultural area. The seedlings are placed in a part shade area that receives sunlight from 7 a.m. to approximately 1 p.m. each day. Media 2 displays the monitoring of growth of mini net lettuce seedlings over a 27-day period. So far during this study, the seedlings have been moved twice during times of heavy rainfall and fast winds. The seedlings were watered and measured every second day, coinciding with the iceberg and cos lettuce water cycles. And this study so far has shown that the 60% water level treatment is having the best effect on the mini net lettuce seedlings.
This is our preliminary results. So the results that we've obtained so far been put in the graph. So our measurement values, so height, weight, and circumference, were obtained by finding the difference between the current measurement date and the previous watering date. To show the progress of the change, all the graphs will be showing a comparison of 3 lettuce species over the 27 days. We picked out the worst and the best treatment result. So the first measurement is height in centimeters. This is the 20% graph, and you can see that everything in here seems to be turbulent in terms of growth. Iceberg lettuce was very apparent in this, and it may be due to the fact that iceberg lettuce have curly leaves, and the leaves may curl up when they lack water. We also only measured the longest leaf, so the drops of the height of the leaf may be due to that. As you can see, minion lettuce showed a stable growth, which is opposed to both iceberg and cos lettuce. And this is the 80% one. It also showed a turbulent result. We can see a big drop in the 21st and 23rd day for cos and iceberg, and this may be due to the storm that we had the day previous, and maybe some leaf have died. And minion lettuce showed again a stable growth.
Here we have two figures indicating the difference in weight in grams for 0% and 80% water treatment across the 3 lettuce varieties. During this study, we decided to include the 0% water treatment level to find the base level water requirement for each lettuce variety. During preliminary discussions, the 0% seedlings were not expected to survive for very long. However, as seen in figure 11, the seedlings did continue to hold on. All varieties of lettuce appeared to lose weight consistently throughout the 27-day period. However, these results demonstrate the possibility of drought resistance of these lettuce varietals. When considering figure 12, it is interesting to note the variance throughout the results for all lettuce varieties. Within this study, weight is indicative of the amount of water being retained in the soil. So if the sample is heavier, then there is a higher water retention. Throughout this study, the 80% water treatment seedlings results indicate this as the optimal water level. This then allows for the climate to have more of an impact on the seedling's weight and leads to a greater variance of results on any given day.
Our preliminary circumference results obtained the most variation between the varieties of lettuce in the 40% and the 100% water treatments. In the 40% water treatment, you can see that the mignonette lettuce was very variable compared to the other varieties of lettuce. And looking back from previous data obtained from the mignonette lettuce, it was noted that the leaves on the outside of the lettuce had died, which corresponded to the drop-off on the circumference from day 19 onwards. In regard to the 100% water treatment, you can see the biggest variation was seen in the iceberg lettuce. And looking back at the data we obtained from the iceberg lettuce, it was found that this dramatic change was due to how the lettuce was growing in the pots, as the iceberg lettuce leaves would grow upwards and then droop down, creating not a circular sphere, but a long oval. And also, the leaves would have been noted to curl in, which would have affected the circumference and therefore made the dramatic changes. So we want to thank you all for listening to our presentation today. And if you have any questions, please feel free to ask.